So now if I try to analyze the response, you will see that the system pole is at -8, right? And when I uh, did the partial fraction, then this part was the uh, pole due to input function, and this was the system part, right? And inverse Laplace transform, this led to 5 by 8. So this I can say is the forced response because this is due to the input, right? And this was due to the system's pole itself, right? And system pole was at equal to -8. So that system pole resulted in the what we call as the natural response of the system. Right? This is the natural response of the system. So how would the forced response look like with time? Only the forced response with time t, it will be constant, right? It will be constant throughout. So this is 5 by 8, and this is how the forced response will look like from here. And how would the natural response look like? Well, at t equal to 0, it will be 3 by 8, right? At t equal to 0, this will be 1, so it will be 3 by 8. It will start from here, and as time goes to infinity, or as the time increases, it will exponentially die out. Okay, so this is the forced response because of the input pole. What do I mean by input pole? Because the input was unit step, so the pole it resulted in the OS what was at s equal to 0. So this s equal to 0 pole is causing this constant response, right? And system pole was at equal to -8, which is causing this exponential decay in the system, right? And zeros usually affect the amplitude of the response. They do not affect the nature of the response, but they usually appear in the amplitude of the response. For example, the 0 was at -5, so you will see that there is 5 here appearing here, right? And they usually affect the amplitude of the response, right? So I can in fact write this down because these observations are quite important and they'll be useful in designing the control system as well, right? So the input pole or the pole due to the input, which was the unit step here, they usually generate the forced response, right? Okay. And since this was at the origin in this particular case, so it generated a constant output, right? Similarly, a pole of the transfer function, so the transfer function pole generates or appears in the natural response. Right. And another observation here is that a pole on the real axis, all the poles in this case were real, right? Poles on the real axis, if it is not on 0, they will always result in exponential response. So poles on a real axis, they will always generate exponential response. So another thing to note here is that if they always generate exponential response. If they are negative, that the response will exponentially die out if they are on the left hand side of the plane. If they are on the right hand side of the plane, for example, had the pole be on s equal to +8, then this response would have exploded from here, right? It would have gone like this, gone to infinity actually with time. And the system would be unstable in that case, right? So poles on the real axis produce the exponential response, right? And the farther it is on the left hand side, the farther decay will be there, right? For example, if this pole would have been on minus 100, so this would have decayed very fast, right? And similarly the other side, if it would have been on plus 100, then it would have gone to infinity much faster, right? And I have already told you that the zeros actually just affect the amplitudes, right, of both the forced and the natural response. So zeros of the system, they affect the amplitude of forced and natural response. Right? Thank you.